For this video, we're going to do a three-field technique, but in this case, we're going to use an AP beam, an RPO beam, and an LPO beam. This technique is often called the Mercedes technique because the beams will resemble the Mercedes logo. To get started, so we're going to insert a new plan. C1 is available, so we'll use that course. We'll leave the plan name as the default plan 1. We will select prostate PTV as our target. The reference point is already in here and created, so we'll go ahead and use that. Let's go with a true beam. Double check your patient position. It should match the scan. Okay, so F1, since it is a central target in a 3D plan, we are going to use a higher energy, 15x. Our isocenter is automatically placed in our target since we selected it during the plan creation process. Let's go ahead and add our DRR and our MLC. Let's go ahead and auto surround with a 1 cm margin. Okay, we have our initial beam ready to go. So now we need our RPO and our LPO. I'm going to copy and paste this beam using Control C and Control V. Now you have two options. You can select this beam, and using this square right here, you can rotate it around to where you want it to be. And you can come here to the Fields tab and look at your gantry rotation, or you can come and just type your gantry angle that you want in. We're going to use 45-degree angle this way and a 45-degree angle this way to make this Mercedes technique. So that is 225 on this side and 135 the other way. So we have this is what this is going to look like. Let's go ahead and redo our MLCs for both of these beams. Let's put our prescription in. We'll use 300 times 10 for this demonstration and calculate. Okay, the first thing I'm going to do is, since we have 3 beams, our plane normalization value right now is based on a weight of 3. But I'm going to click F3, change that back to 1. Now it's based on a weight of 1. So you can see here, since we have our 3 beams, 2 of them are coming more posteriorly, that a lot of our dose is posterior. So let's try to even that out by adding a little bit more weight to our AP beam. You can see how that changes the isodose distribution. So again, you're going to kind of weight this depending on what objectives you're going for. In this case, we're just going to try to get a more conformal plan than just your typical APPA distribution looks like. So I think this weighting looks okay. You can see it does conform more. We don't have our high prescription isodose lines going all the way to the front of the patient and all the way to the back. You can see what this does though is it still leaves a hot spot back here. So what we're going to do is we can deal with that 2 different ways. One way is by adding wedges or EDWs to these 2 fields right here. That'll kind of skew the dose further away and even out this dose distribution, or we can take care of it with field and fields. We'll start with the wedges. So on this machine right here, we don't have physical wedges, we have EDWs, and the way EDWs work is, let me go ahead and turn off those 3D dose clouds. So our EDWs only go or come from our Y jaw directions. And what we want to do is we want to push the dose across in the X jaw direction, or our current X jaw direction. So what we need to do is rotate these two beams. And actually we can just come here to our Fields tab, and we have our collimator rotation here. We need to rotate both of these to 90 degrees. You can see that that messes up our MLC pattern, so we need to redo our auto fit. Now we can add our EDWs. So let's right click on F2, come here to Properties, up here to the Accessories tab, and we have our dynamic wedges. So we don't need to, this is not a huge hotspot, so we do not need a large amount of EDWs. So let's start small. We'll start with the smallest there is, 10. I always forget which direction is which, so we can tell the EDW to come from the Y2 direction and move across this way, or we can tell it to come from Y1 and move this way. I always just have to pick one, hit apply, and take a look. So right now you can see the heel is over here and it's going to push dose this way, which is the opposite of what we want. So I'm going to select this one out. Now it looks how we want it. The heel is over here. It's going to skew that dose distribution in this direction, hopefully removing this hotspot. So let's go ahead and do it to F3 too. There we go. So both our heels are together, which is what you always want. You never want to have your heels facing away from each other on different beams. You always want your heels facing each other. So let's go ahead and compute and see what this does to our isodose distribution. I think that's pretty good. So hotspot at 105.4 is actually really good. It's a fairly homogeneous plan, but let's just change this to 15 degrees and see if that helps even more. 15 and 15. There we go. So now our hotspot's even better, less than 105. And you can see every time I do that, the hotspot will reduce in the back here, and our coverage or our higher isodose lines will cover better in the front. So that's one way to do these plans. It's a very simple way. Let's revert back here. So I'm going to copy this plan using C or Control C and Control V. Let's remove these EDWs. So to remove an EDW, you actually just have to highlight it in here and click the delete key and apply. Same thing here. Let's put our collimators back to 0. Redo our auto surround and recompute. So basically we just undid everything we needed to do in order to create our EDW plan. It's going to put our isodose distribution back to the way it was, so it's just skewed a little bit to the posterior side here. Let's try to get rid of all that 105 like we did for the EDWs. So I'm going to come here to isodose levels. I'm going to turn 105 on in 3D. I'm going to turn it from contour to segment. And now I'm going to start adding field and fields. So I'm going to turn off our prostate PTV volume so I can see a little better. I don't want to add anything to F1. And the reason I don't want to add anything to our AP beam, or F1, is you can see here, this hot area that we want to block is right in the center. So in order to get my emulsives to this volume, I would have to cover everything over here or everything over here, and this is cold. So as soon as I start to cover this, it's going to get even colder, and we'll lose coverage, which will force our plan to normalize lower. It'll have to basically bump up the total monitor units in order to maintain this coverage and make our plan actually hot. So we don't want to use this field to create fin fields. We want to use these two, where that volume we want to try to make disappear is on the edge. So let's start with F2, new field and field. I'm going to select the leaves that I want to move. Oops. I'm going to tell them to contour right to the back edge of this volume. Add 3% and calculate. You can see how that volume got significantly smaller. Let's go to the other side. It's very close, only 0.3 away, so let's try just adding a little bit more weight maybe. Let's go to our other side. So in order to bring back up our F2 beams, I can use the filter down here. So right now it's filtering only to F3. If we just change that to F2, now we're looking at our F2 beams. We can add 0.5% to our F2 field and field. And there we go. Our 105 is all gone. Distribution looks good. Our plan is slightly more conformal than our standard APPA. These two plans, if we just drag them over a few times, you can see that distribution is very, very similar. This one uses EDWs. This one is using fill and fields. This plan, we would merge these by going to planning, merge subfields to create our final plan. But there you have it, two different ways to use this Mercedes technique.